Good afternoon, everyone. I'd like to welcome you to this 40th anniversary panel, or this panel on 40th anniversary topics, or this topic, or this panel that happens during the 40th anniversary LCN, whichever way you want to choose to go about it. My name is Tim Strayer, and I'm from BBN Technologies, along with Joe Bumbless. We were the committee for the 40th anniversary celebration. Part of that celebration is to assemble this panel, panel of esteemed people to answer questions. We had three criteria when we invited people to be on the panel. The first criteria is that they had some history, some deep history with LCN. The second criteria is that they have deep history with networking. And the third criteria is that they've got deep opinions on both. And so I invite you to be very candid with your questions and then be very candid with their answers. I'm going to hear the rules of engagement. I'm going to get them to introduce themselves first and ask them to say when it was that they were first at LCN and what they were working on when they first came to LCN. Then I'm going to have privilege of being the moderator. I'm going to ask the first question. After that, then please, if you have a question, you can come up and queue over at this mic. If you feel that that's too much work, you're more than welcome to be very, very loud from your seat. But this is the preferred method. So with that, I'm going to, without any more ado, start with Peter. Could you please introduce yourself?
Yes, my name is Peter Martini. I started with LCN and LCN40 in 1989. By that time I was a postdoc at the University of Aachen in Germany, and I worked on the area of, my first paper was entitled here at LCN, Fairness Issues of the DQDB Protocol. Thank you. And then I continued being with LCN while I was professor at the University of Paderborn in Germany from 1990 to 96. And I stayed with LCN after I changed to the University of Bonn in 1996. And actually I was also the first European coordinator for LCN. I happened to accept a call which was given that the conference was held in Minneapolis. There was a specific table of the organizing committee at lunch, and everybody was invited who was interested in joining the efforts to work for the conference. And I went there, and then in the final session, I came to know by the announcement, I think it was Jim Moore now, who was closely associated with DQDB at the time. He announced that I would be the first European coordinator. If you're interested, you can ask me more, what is the job of the European coordinator? What has it been?
Hi, I'm Harvey Freeman, and my first LCN was the third one in 1978. And I had been working for Sperry Univac, which brought me to Minnesota in their defense systems division on a project that was really one of the first local networks. They built this network at the memory level that would sit between mainframe computers and memory and be able to send information around this ring to a particular site. And the first two were the Network Systems Group, which had a similar device that they made commercially. And they decided that they wanted to get out of that business of conferencing and telling people what they really did. And the University of Minnesota took over for a year, and then we got the IEEE Computer Society involved. Then the Computer Society has been the sponsor of that ever since. I had moved into, by that time, Sperry Univac's commercial division, where they just started looking at networks. That was a real problem then, because anything that wasn't a mainframe they weren't interested in. So the many ideas that my research group had never went anywhere. And then I left there in 1981, and a friend and I started the first local network consulting company, which is how I met most of the people here.
Howard Salwen. I don't know, I might have come to the second one of these. I might have come to the second one of these sessions. I've been working in networks for a long time. I'm the founder of a company called Proteon. Actually, Proteon is long gone. But we did networks for people. For example, in the 70s, we did a fairly large network hooking together oil drilling systems for the Gulf of Kuwait. And so we're always in that business, and when 802 came along, we were very active and made our contributions. And I think maybe I don't want to get into competition with partner. Maybe I was at the second LCN. I'm not really sure, but it's possible. It's possible. I'm very happy to be here, and I'm very happy to see everybody is still interested in networks. Isn't that miracle? Thank you.
I'm Bob Metcalfe, and the Ethernet paper was published in July of '76, and the first meeting of this group was in September of '76 at LCN. But I don't remember if I came here to that, but I eventually got here to number 3, I think. And then I moved from engineering, science and engineering, over to entrepreneurship, and so I stopped coming for the 30 years, and now I'm back.
You were there in the 7th.
The 7th also.
Yeah, you gave the keynote speech for that one.
Oh, and one of those was on FiberNet, one of the keynote speeches I noticed, which was a fiber optic Ethernet.
That was probably the 7th one, because he was talking about fiber optics in 1977, 78.
Well, FiberNet was done in '76. Well, maybe. So you wanted to hear how long we've been associated with us? Sure. Yeah. That's how long.
Okay, so one of the hallmarks of LCN, one of the things that's been a lot of fun to go back and do is when looking over the history of the papers that have been in LCN, you get to see kind of a roadmap of the things that have been really hot and the things that have generated a lot of interest in people. And so my first question to the panel is this. If you look back on some really, really hot ideas at the time, I'm curious what you think are some ideas that were hot then and you're surprised now that they didn't make it.
So there was a paper published called the Data Reconfiguration Service, published in the 70s. And I was one of the co-authors. There were about 10 co-authors. The idea there is we were hooking together all these computers, some from IBM, some from DEC, some from Wang, some from Data General, blah, blah, blah. And they all had different data formats. So the Data Reconfiguration Service was going to be a way of programming a conversion facility to convert from any format to any other format. And it never happened. It proved too hard. And it seemed that what seemed simpler was just to make a standard and then just do the standard rather than try to convert all sorts of non-standards to each other. So that would be an example. The Data Reconfiguration Service, you can look it up, it got published.
I think we did pretty well. You know, it's the people are here, and people have been coming to this thing annually for a long time, and look at all the networks that are out there in the world. I think we did pretty well, and they almost all interoperate with each other. It's a miracle.
Howard, what about a really good idea of the time that isn't here?
I need a couple of minutes.
Yeah, sure.
Anything besides Ethernet?
Well, FPDI, for example.
Oh, FPDI, that's good.
There you go.
Yeah, I spent a lot of time on FPDI. I spent a lot of time on things that did not come to really exist, like token rings. I gave my heart to the token ring, and I couldn't beat all of that money that was going into Ethernet. You know, when I had a small company, about 20, 30, 40 people, it was, for me, that seemed small, but maybe to you it seems small. And to go and compete against the Ethernet steamroller, I'd like to say that they $50 million for marketing, and I had $50.
But your company had 500 employees that went public later.
That was later. That was after I took
A
over.
big proteon behemoth, Steve.
I wish.
You had IBM on your side, excuse me.
That's not necessarily the advantage. They have their own ideas. In any case, I really enjoyed every minute of it. I was saying, I enjoyed coming to these meetings, and I enjoyed working on networks all of this time. Wonderful.
Up until 1995, the network was in, this networking conference was in Minneapolis. And the reason was it started there because 4 of the 5 top computer companies, Cray, Honeywell, Sperry Univac, Control Data, were located there. And they spun network systems, CNT, and other networking companies. But as we know, they all went out of business. All the networking engineers migrated to the West Coast. And by 1995, we were really only having about 60 people at the conference, 50 people presenting papers, and 10 members of the organizing committee. And fortunately, Frank and others decided to salvage the conference by moving it out of Minneapolis, and they really made it like it used to be, with a couple hundred people attending.
Okay, in my introduction I already mentioned the title of my first paper, and there was the name DQDB included. And for those of you who do not know what DQDB stands for, it was Distributed Queue Dual Bus, and it was supposed to be kind of an access network, a metropolitan area network, or a customer premises network, providing the access to the ATM network. And I guess most of you, when hearing ATM, you think about these teller machines, but what about these ATM cells, 53-byte long cells, designed in the late or mid-1980s, with the general purpose being to design a broadband integrated services digital network. It was nothing less than the unification of the telecommunication networks and the computer networks, aiming at to have something for both communities, both high bandwidth and also the support of low latency and real-time traffic. And at that time, everybody, and I attended also the IEEE 802 meetings many times, and I recall a time when everybody, especially at IEEE 802, almost everybody was thinking that, well, the time for Ethernet was over. Everything had been done, which could be done to that technology. There was something like 20 or even less people attending the meeting of IEEE 802.3. And then, all of a sudden, at the next meeting, everybody was going for the 100 meg Ethernet. Suddenly, something like 500 people showing up. Well, the walls were too small, and I was impressed at that time how the process of standardization was handled. I had seen what happened to DQDB. As far as the standardization was concerned, it was really not good. And therefore, the high-speed version of Ethernet, they started with a time plan, saying at what point in time what should have happened. And so this was to make sure, and it really worked, to make sure that in time, before really ATM could have taken off, have access to all the end systems, to make some alternative available. Some other kind of technology, much cheaper, much easier to handle. And so it was, after a short time, it was quite obvious that this would be a big success. But as I said, in the late 1980s, the majority of people was thinking that the future of high-speed networking would be based on ATM. And now there are still some ATM stations around, but the final ones are shut down, basically at that point in time in the next few months. So.
Yeah, there was a real war.
Yeah.
All the different protocols. Yeah, ATM was just one of many. And of course, there were people that wanted to do Ethernet at a gigabit, and it didn't work.
Yeah.
And it was simple to analyze. There were people that published but there are other people that just wanted to do it anyway.
You
So
also-
we ended up in a pretty good place.
At our university, we also tried to really implement or use the ATM network. It was awfully expensive, it was extremely hard to manage, and it was obvious that first you had to spend lots of money on your staff to learn how to work with that. And so we left it as soon as possible.
Yes, I used to go to the standards meetings, and that was exciting because there was a lot of friction.
Talking about standards, I was the chair of the Computer Society's Technical Committee on Computer Communications in 1980 and 1981. And so early in 1980, I got a call from Maris Grauby, who was a network engineer at Tektronix in Portland, Oregon, who said he started his standards committee and he was looking for a home. You know, can the Technical Committee on Computer Communications be that home? And I said, sure, why not? Little did I know, when the call started from Dan Pitt at IBM and the Ethernet people, you know, you got to support our standards. So we ended up having Bob back for the 7th. We had John Schock for the 9th. And I think we prevailed on the Ethernet with having just the right speakers come.
So I'm going to remind you that rarely are you going to have a chance to ask questions of such, so much knowledge, people who embody so much knowledge. So please avail yourself of that. In the meantime, ISO, OSI, reference model, and protocols. Were they like a great idea? Was it a net win? Or are they just basically a historical artifact and a good teaching tool? Go, please.
Does everyone know the ISO reference model? 7 layers. Okay. I think it was one of the best ideas ever had, and it helped the internet be successful. But then there were the ISO, the OSI protocols, and they worked. They can be shown to work, just like TCP/IP. And they were adopted by all the major companies, IBM and AT&T and many others. But then a mistake was made. Now this is controversial, but the mistake was this. The Corporation for Open Systems, of which all those people were members and it was the champion of OSI, I was the chairman of that organization. And I watched us decide that conformance was the most important thing. So we developed conformance tests to be sure that we could test the implementations of our members against the standard and be sure they conformed. Whereas the Ethernet TCP/IP world was not wrapped around conformance, it was wrapped around interoperability. So you may have heard of a conference called Interop. It was originally what was his name? Dan Lynch formed Interop, and there all the competing vendors brought their Ethernets and we hooked them to each other and debugged them right there on the show floor to be sure they could all interoperate. So I think the lesson from that interaction was interoperability is more robust than conformance.
Other opinions, please?
Well, I recall from that time, the late 1980s, that whenever we wanted to buy networking equipment, to get it through the university administration, we had to state specific reasons why we wanted to buy something based on TCP and IP, instead of buying some equipment based on the OSI protocols. And the usual explanation was that, of course, for the purposes we had, there was no implementation available, it was much too expensive, and explain, of course, it's only as a transient technology, only for 2 years or so, and then we will change, we promise we will change to the OSI protocols, and then 2 years later, again, we promise that we put something. So it caused some additional work to give explanations why not buy it, but otherwise, in our area, everybody wanted to go TCP/IP for teaching, whereas the ISO reference model with its 7 layers, the first 4 layers are fine. You could argue about layers 5, 6, and 7. Usually when I'm teaching at the end of the semester, I've reached all the areas of 1, 2, 3, and 4, and suddenly there's not so much time left for discussing the details about the layers 5, 6, and 7, and the students seem to be very happy with that. And me too.
Well, the interoperability was always a problem. We did it pretty well because quite a bit of it worked, but a lot of it did not work, and it kept us busy for years. People had their own ideas, people had their own requirements, and so it was not easy to get to where we are now, where pretty much everybody does the same thing. Like I said a few minutes ago, it's a miracle.
Everyone used the standard, but then they enhanced it. Bob mentioned interop. One of the things that's the real hot topic today in IEEE and the Computer Communication Society is the interoperation of things. And back in the 70s, at the first interop, they demonstrated how a toaster could work on a network. So that was probably the first IoT demonstration.
You know, I think you're right about that. I remember the toaster.
Yeah.
So where do standards fit into all of this? Standards good, bad, indifferent?
Essential.
Essential.
Essential, you know.
Right. Okay. So you've got the IETF that puts out standards with a lowercase s. And they're a group of people that bring everybody together. And they basically say working code, general consensus. And then you've got very formal government organizations with people like secretariats and stuff like that. So let's get an argument going here.
Well, you know, even if you try to conform to the standard, language is flexible
Yeah.
and subject to misinterpretation. So you can insist that you are conforming to the standard, like it says right here, and then the next person says, no, I'm conforming, it says, and the interpretation of that particular line that I'm pointing to is different here and there, and the stuff doesn't work. So the interoperability, it was really something that had to be demonstrated, but we did very, very well. So much stuff works together. Not at first. First, it was really difficult to find out why it didn't work. And you're dealing with another company. It's not your company. You're in some strange place. This wasn't easy, but we did it. We being us.
Yes, please.
I'd like to add upon what standards. Of course, I agree that standards aren't essential. On the other hand, most of the standards that we have today are completely useless because there are some of them which you simply cannot implement, and there are others which have been implemented where you have interoperable implementations, but no business case, no company backing that, no user really needing this. Only some, say maybe some PhD students finished their PhD based on these specific topics, and they learned about it for themselves, of course. And there may be useful input on some projects related to that. But what I learned very early is that it's definitely not, it's very important to have this working code, but it's still not enough. Still, it's important to have some strong company backing, otherwise you have a nice technology and nobody will have the revenue.
So what replaced Interop then as the place where people meet to make sure that things are compatible? So then how does it work?
Well, it works that the vendors visit each other.
Or you could have a very strong customer. We had a very strong customer. And that customer bought equipment from a lot of different sources. And he insisted that it would all be interoperable, or else. So that got us moving.
There aren't any customers here. So we can talk about them.
No, I don't see any of my customers here.
The customers were, I'm just amplifying your point, were put lots of pressure on being interoperable.
Absolutely.
had to be. And there were lots of bake-offs and competition where you had to show that you were interoperable. That all worked. It was a struggle. You know, in 1979, DEC, Intel, and Xerox, DEC, then the number 2 computer company in the world, Intel, and Xerox, the number 2 office products, decided to do Ethernet together. And then we had an antitrust problem. Then everyone was suing IBM for antitrust, and then someone said, well, maybe this cabal of 3 companies is in antitrust. So I'll make a long story short, we needed a standards body. So we had a meeting, and we admired HPIB standardization, IEEE 488, which had just finished. And so those people, the 488 people, demonstrated they knew how to make a standard, so we adopted them. What was it? Don Lockery was the guy at HP. We recruited Don to 802. And so, I mean, that explains some of the effectiveness of the 802, is it was built on something that had been proven to work, which was HP's 488. Then HP joined the Ethernet standardization effort, and unfortunately, they joined the Ethernet branch of that standardization.
Yeah, there was another competitive technology which nobody remembers, called token ring. And I spent a considerable portion of my life explaining why token ring was really good, and how Ethernet was just push to talk like your CB radio. Didn't work. But the token ring had more performance, and nobody was really that interested in the performance that the system could provide until they started trying to go 100 megabits per second and a gigabit per second. Then performance was really expensive, and they did not use the original Ethernet technology. Ethernet is a thing like, as I said, it's like you listen, if nobody's talking, you talk. It's just like CB radio.
I think the early days of LCN were really important because it established local networks as a discipline net, as something separate from the X25 networks, from the telephone networks and things like that. It offered an opportunity for people to come and present research papers on what they were doing. Before, they were just scattered about. And obviously, once this conference got started, there were other conferences that mimicked it or added whole sections to it and greatly expanded the field. But I think this conference was instrumental in going forward in an area that people really hadn't thought much about.
And the interoperability was essential for the success. And we test our interoperability at these events. Very important.
So in 76, 77, in there were 2, to my way of thinking, there were 2 important plans, local area networks, although they weren't called plans yet. One was Network Systems Corporation's Hyperchannel, and the other one was Data Point's ArcNet. They were both out front, of course, on opposite ends of the spectrum, one aimed at PCs, the other aimed at mainframes. And I think many of us made the trip to Minnesota because that's where Network Systems Corporation was, and that's where the Hyperchannel was.
They were formed by ex-control data people. So they knew mainframes, and they brought in some networking people, and that's how they put it together.
So I now live in Austin, Texas, and San Antonio is right nearby. And they're still bitter there about the Data Point ArcNet thing.
Well, there's a lot to be bitter about. Things that were really good that were just left by the side of the road.
Nils, let's go with Nils, and then
yeah, I think I'll start with a question. So, you've mentioned several times the protocol wars, right? The protocol was just on layer 2, or did you have also wars in other layers? Because layer 2 we now have heard that Ethernet had one and kick out all the others. But how about the other layers?
Well, I'm supposed to be a moderator, but I think I'm the person who's maybe most qualified to answer this to start. So I'm not going to get exactly which LCNs they were, but around in the late 80s and the early 90s, there was, all of a sudden, TCP became a target, a moving target, one that a lot of really great researchers decided to take their aim at. And so a bunch of people started coming up with some really cool ideas for transport layer protocols. TCP was considered to be a terrific protocol, but it proved its point and then it was time to move along. And so some very, very good thinking was done about how to do things better. There was people who thought about how to make a completely transaction-oriented protocol. There were people who thought about how to make a bulk data transport protocol, things that were very much focused on that. And here's what happened, and here's what ended up happening. What happened was that there was a group of people centered around a protocol called XTP, Express Transport Protocol. It was actually called Express Transfer Protocol at the time because XTP blurred together the layer 4 and layer 3. And that actually was something that the French had decided to do, and so XTP started doing it. A fellow by the name of Greg Chesson was the guy who started that, and then a few people sort of congealed around him, and a whole company was started called Protocol Engines, and the idea was to take, in the same way that FDDI had taken things into silicon, they were going to take the transport layer into silicon, transport and network layer into silicon. And people were thinking that can't be done. There's just, you can't do that because the formats were wrong. Well, so this whole protocol was built around that. So while XTP was being talked about here at this very conference, several people who were staunch TCP supporters came to the conference. Dave Clark, I think, and a couple of others who stood up and said, we can do TCP in silicon, and we can do TCP with 16 instructions. And it went back and forth. And in a panel very much like this, it got a little bit impolite, but it was still fun. And it was one of the highlights of the time to see people really strenuously debating and talking over each other about the benefits of one particular way or another. And I'll say that Greg Chesson was a forward thinker in a lot of ways. One of the things that he said was, I can't tell you what the protocol, the transport protocol of the future will look like, but I can tell you what it will be called. It will be called TCP. And he was completely right.
That's right.
And if you go back, and I recommend that you do, go look at some of these protocols in the early 80s and the late 80s and the early 90s. And if you catch me, I can recommend a book. If you look at those protocols, you'll see that a lot of the great ideas that were in those protocols and not in TCP have subsequently shown up in TCP, like selective acknowledgements and negative acknowledgements and various other things like that. So that was the protocol wars. Do you guys have something to say?
That was not the protocol. That was a fight inside of the TCP world.
That's true.
The rest of us had to deal with SNA and NetNet and IMNet and DoodleNet and Data General Net and all these nets.
Which brought you routers. That's how routers came into existence.
And
We had to deal with everything.
So Xerox early on had an internet inside the company based on a set of protocols called XNS, Xerox Network System. So prior to 94, let's say 94 is the emergence of the web when the internet really took off. Prior to 94, the dominant protocol was XNS. 3Com was peddling Ether Series, which was based on XNS, and Novell had NetWare based on XNS, and all the packets in the world were XNS packets. And then, so I was on the losing end of that one, because then 3Com sold TCP, but not successfully for a long time, and then TCP took off, and then all the others went away. And that's the real protocol, I think.
Yeah, I think that the decisions that were made in the 90s were based on the capabilities of semiconductors to do the algorithms. And the semiconductor capability was zooming and soaring, and you could do more and more without any more equipment. Just put it in the chip. I think that changed everything. I think that we were afraid of certain protocols because they would use up certain machine cycles, and it became irrelevant. It helped us out a lot. Didn't have to do as much thinking. Anyway, go ahead.
Any other thoughts on this? Thank you for the question, Bills.
So my question is, how much of a role do non-technical factors play in the success of a product or a protocol? I can kind of give 3 examples. Right? I think partly the success of the original internet was due to the fact that there was a strong advocate and simplicity. We never look at simplicity as technical. And later on, if money is a factor, we will all be using ISDN, right? And then later on, when I think when it came time for 100 megabit per second Ethernet, I think there was a fight for the name Ethernet. So at that point, somehow branding became very important. Right? So my question is, how much do these other factors, other than the performance values and other things that we look at in these conferences, play in the success of a technology?
Well, if among the technologies that work, that is, there's sort of a semi-finals, then you get to the finals where all the technologies have to work, and then technical relative merits become much less important once everything works. Token ring worked, Ethernet worked, RPAD works. They all work. And then the non-technical factors come in. To answer your question, I think that comes later. Let's see.
I think I've repressed all of my knowledge about the machines that didn't work. And there were a considerable number of things we went to great effort to get the place wired. One thing that we did for a government agency, it wasn't an agency, that's it had very neatly placed wires stapled to the wall, and it was really neat, but it didn't work.
So I think part of the question is too, like, what factors made, what other factors can you think of that shape the technology, the evolution of technology? If it's purely merit, then we're living in the wrong world. That's not true. I mean, there's a lot to be said about various things, Betamax and VHS, things like that. So what other factors here?
I think a major point which has not been really well understood in computer science is that technological aspect is one point, time backing is a different important point, but usability is an additional point. How humans can work with these systems, how complicated it is to administer a network or a machine. In mechanical engineering, decades ago, they started establishing chairs at universities on ergonomics, addressing the challenge of not only building a good machine, but also to help humans to work with these machines, the whole day long, not becoming ill, in order to reduce the number of mistakes they make when they're working with these machines. And in computer science, but especially if you have a look at the security area, it's extremely hard, even if it's technical, everything fine, it's really hard to do it in the appropriate way. And as I mentioned earlier, setting up an ATM network was such a mess that everybody, all the technicians were happy when these higher layers, the company decided to go away from that and simply use Ethernet, because it was a much simpler technology. It was so much simpler to work with that. And so if you ever tried to get the correct way to enter the ATM address of a specific device. You had to do it through so many numbers. The probability was so high to put in one of these numbers in the wrong way that they don't get away with that. And so the question of usability, I think, is something which must be stressed more, and which already had in the past a strong impact when it came to adopting or not adopting some technology.
I'd like to go back to the question. I think there was a classic personality type in the world who was bitter that their technically superior solution was not adopted. It's some huge conspiracy of some kind kept them from achieving technical superiority. And I advise all of you who may be tempted to that point of view to abandon it, because it is a dead end. It has a lot to do with understanding what customers want. And so what seems to be a technical merit may not be a technical merit to the people who have problems that they're trying to solve. So if there's any Betamax people left, give it up, guys. So I had to give up. XNS got beat by TCP, and I had to swallow that. And XNS was better, I want you to know. But it got overtaken by TCP with all that research that got done. So the research community was focused on improving TCP, and there was no similar effort on XNS, for example. So the LCN movement probably bolstered TCP. So in the long run, it had technical merit eventually won in the case of TCP.
Everyone's talking about the merits of Ethernet and whatever. I think the real key wasn't technical superiority, was price. I think the Ethernet costs dropped faster than anyone else's technology. And sure as hell, that's what people were going to buy, because they could get a lot more of it for their money.
The Ethernet cracked through the marketplace. And how that happened, I was there the entire time, and I can't tell you what happened. It just won. And when it won, the volumes went up and the price went down. It's plain old business. I think always there are better products, not just in networking, but in everything, that don't win. They get left by the side of the road. And I think that Ethernet worked. It certainly was not the best technique. They tried to move it as is to 102 gigabit, and then they just couldn't keep that technology. They had to change it, and they said, no matter what we do, we're going to call it Ethernet.
Yeah, very good example. Harry Saul should probably be here on this panel. And he had an early network, Nestar.
Yeah.
That
Cluster
was focused on, what was it called? Cluster A?
Cluster A, yeah.
Was focused on Apple IIs. And Harry is a very ethical and hardworking guy. And he figured networking was too complicated for most users. So he built a direct sales force with very strong field service, and which is very expensive. And then he brought Cluster A to market. Whereas 3Com, the retail store for PCs got invented in exactly the right month for us. So instead of building a direct sales force, we just put our products through the business land, computer land, all these stores out there. And this is an example of a non-technical advantage. That decision right there, very strong example. So Netstar eventually got out-leveraged. We went through huge distribution channels, eventually through distributors, where Harry was selling one at a time, direct. So that a distribution decision was instrumental in the eventual success of Ethernet.
Don't worry about it, he did all right.
Cluster 1 was my first network, and when he saw the handwriting on the wall, he folded Nestar and formed Network General, and they came out with the first Ethernet tester that became the the standard tester and everyone bought.
So Harvey mentioned briefly about the Internet of Things, right? And if you look at what's happening out there, you have, again, perhaps some parallels in that you have all these standards coming out, Z-Link, Zigbee, Cisco-PAN, Bluetooth. So do you see any parallels with what's happening now and what happened in the 70s? And do you perhaps see a clear winner like Ethernet? And would you have some advice for those of us working in the IoT based on your experience?
It's a hard question to answer. The main thing that has to happen is interoperability. That's the driving function. The successful, I think that Ethernet won because the stuff that different companies made worked with each other, and that was two or three reasons. One is that the protocol is fairly simple. It's not a complex thing. And the other is that the companies realized that they had to be interoperable to be successful. And so they did it. And I worked on some other things where that didn't happen.
I assume that the communication between the Internet of Things is going to be wireless, and we do have wireless standards. So if you conform to the wireless standards, you can put whatever you want in your refrigerator or toaster or whatever to get it to do the functions you need.
But the fights probably, to build on your point, would be higher than the plumbing standards. So the hard part of the upper level protocols and how they're going to touch. So there should be a network, Internet of Things interop conference in which people hook their nests to their some other thing and demonstrate that it's somehow compatible, and that will probably work again for the Internet of Things. I don't think the standards have emerged. I'm a Zigbee bigot because I invested in a company called Ember that developed it. But Zigbee spent most of its time not on the low-level plumbing, which it did, but on the profiles of different applications like home networking, industrial networking, and so on. That's the hard part up here, I think.
You know, you remind me of another element of this whole process, and that is the customers. Some very big, very powerful customers insisted on interoperability and forced all of us to make changes where necessary so that they could buy products from a whole bunch of sources that work together. And include three-letter names. Right.
When thinking about the Internet of Things, of course, we have to be aware of the fact that there are so many different things with so many different requirements. And this reminds me of these discussions in the 1980s about this broadband integrated services digital network. There were some obvious applications which everybody needed as soon as possible. And there was a real market, there was a business case, and the technology is meeting these customer demands, they made it. There was a lot of additional dreams, what else you could do with this new kind of network. Or these guaranteed service things. At some point of the discussion, somebody came up saying, well, guaranteed service is what everybody wants and nobody can afford. And in fact, when it comes to really paying for that, and when it came to really specifying what exactly are the requirements as far as real-time communication, as far as guaranteed loss of packet things and so on, latencies are concerned, then it became very, very complicated to figure out where there was a significantly large market to address, where there really was a business case in that area. And so a lot of dreams did not come true, or they came true in a different way, because Internet was becoming so cheap, bandwidth was available more and more, and so instead of thinking of how to manage the available bandwidth, in many cases simply bandwidth was thrown at this problem. Today, of course, Harvey is right, we will see a lot of wireless communication, and when it comes to lines, especially if you're able to use optical transmission, then basically you have as much bandwidth as you like. Physics is different when it comes to wireless communication. And it may be that there's enough space for other things. We had this excellent presentation this morning in the best paper candidate session about specific requirements and how to address this with a special version of Ethernet. When it comes to communication inside the car. Another point is what we call in Germany Industry 4.0, making the robots interact in a completely different way with the humans. Moving around, the humans being close to them while they move around. And there's a lot of different kinds of real-time communication required. There's a reduction of latencies required. When I was driving to the airport in Germany, it was amazing to me when I got to the motorway. I have also internet radio in my car, and I chose some radio station from the Tampa area. And so I could listen to the radio from this area here. It worked fine. It even worked at 100 miles per hour. In Germany. Then I said to myself, well, the only thing that is bad is it takes so long until the music starts. Because it is not real-time communication really, but they have a lot of buffer inside. And after this buffer is filled, it works fine. So there is a huge latency in this network. Basically anywhere you go in the wireless world, almost any place you will find huge latencies. And in some cases in the Internet of Things get broken if you have no connection to a very specific amount of time. But what I see also in discussions with companies interested in that, they have a very hard time in specifying what is really the requirement in this context. And what I also learned in the past, the European Commission spent millions and millions and millions in studying customer requirements. And what I learned there is, first of all, it took a lot of time to understand the customer requirements. Then the product was built, or prototype was built. Then the customer said, this is not what I meant. I meant something different. And then, some years later, they presented what the customer meant. And then he said, well, this is what I meant 3 years ago. Now I need something different. And so it's a very hard time that you have if you really want to understand what really are the customer requirements in some new area, and to make sure that the market is large enough for major companies to go for that and make products cheap enough in order to be adopted.
Or it could be like Apple, tell the customer what their requirements are.
Yeah.
That's also possible.
Could I add a whole other set of considerations? At the beginning of the internet, we had two monopolies. AT&T monopolized communications and IBM monopolized computing. And in the course of the building of the internet, those two monopolies were broken. And I think that helped us build the internet. So now comes the Internet of Things. And guess what's happening? The FCC is deciding that the internet should, the US FCC is now deciding that the internet should be regulated like a utility, like it was back at the beginning of the internet. And that'll be a big, I hope they are thwarted in that effort, but if not, that'll be a different factor. You'll have to keep your eye on these regulatory bodies.
Other questions? Yes, please. Thank you.
Yeah, so you told us about the good ideas that didn't make it. What's, in your opinion, the worst idea that did make it?
The worst idea that did make it. The worst idea that did make it.
Can you come back in an hour? There's things that, from my perspective, trying to realize a product based on some really bad standard is, let me think of one. I don't want to do that in public. But there are lots of things that are standardized that have no business being standard. And we, the manufacturers, or the designers and manufacturers, have to do it. Especially if the customers demand it, that's important.
So this is a really old example. Does anyone remember the 3270? That was the dominant IBM terminal of the early 80s.
Absolutely. I was running a lot on one of those.
So 3Com developed a 3270 emulator that ran on a PC and then used the Ethernet to go to some remote IBM mainframe. And our engineers and marketing people worked on it for a very long time, and finally the big moment came where I was going to go look at it as head of sales and marketing. And I looked at this horrible kludge on the screen with little arrows and things on it, and I said, we can't ship this piece of junk. And I said, Bob, this is what a 3270 looks like. So that would be an example of a bad idea that made it. Of course, they're not around anymore. Is that right? You're all regular users of the 3270. Well, we can come up with some other examples, more recent than that, perhaps.
Somebody help us out here. What do you got back in your office?
Other questions? So yes, please.
So first a comment, I think as the networking community, we can be very proud of what networking has done to better the lives of people. But at the same time, do you see any dark clouds over the horizon? I'm specifically thinking about things like privacy. And is there a role for researchers, engineers who come to conferences like this to play in universities?
Dark clouds.
Well, there definitely needs to be continued work on privacy and security, but I want to assure you, having been attending computer conferences since the 60s, there's been a dark cloud over the internet and computing the whole time. It's not as if privacy and security is a recent event. I wrote RFC 602, I think it was, in December of 1973, pointing out that the internet was vulnerable to being hacked. And we still haven't fixed it. So it's not the end of the world. There are these clouds, and we all need to be working on it, but it's not any different than it's ever been, I don't think. It's the major vulnerability that we've left behind for the internet. It's just too easy for bad actors to play around. We need to fix that, so please fix that. We all.
Please.
Yes, also to me it's a very important topic to address privacy, and at our university, in particular at my chair, we established a junior professorship exactly in that area. The real challenge there is, again, I'm talking about the issue of the business case. There has been a lot of examples in the past. How much is an ordinary customer willing to pay for an improvement of privacy, even if you can prove that privacy improved? Is it $1 per month? Is it 10 cents per month? Is it $5? $5? No. $1? I doubt. There really will be a majority willing to pay at least just $1 for significantly improved privacy. If I see in Germany when these people are presenting their customer cards at the cashier, or to make sure that they get completely tracked. Everybody is eager not to be spied upon by the government, by police, or by whoever, but then they are presenting their customer cards there and they get a small percentage of a percent as a discount. In the beginning it was much more. Nobody really cares about how much discount you get if you're presenting this card. If you're paying, this is payback. And so, obviously, there is not really enough awareness of that area. We are aware of what can be done, we are aware of what kind of tracking can be done in this context, but the only explanation to me is that the majority of people simply is not aware of the risks that are running in this context. Otherwise, they would be willing to pay, let's say, $1 a month.
One of my supporters and mentors is a professor at MIT, and he wrote a paper called End-to-End Processes in Local Area Networks. It's a fairly famous paper. And one of the end-to-end processes is security, encryption. That's the solution. You can't do anything with the networks themselves. They can always be tapped with a little soldering iron. But what we can do with the digital capabilities that we now have, we can encrypt even speech like this. Anything you want to encrypt, you can encrypt at speed these days. That's the answer. Of course, it adds a layer, but it's the answer. If you really want security, that's the way to do it.
Yeah, I have to say, of course, you can encrypt everything. You can also perfectly encrypt the worst malware you can imagine and deliver that up to the end system. And then try to have an idea well, how the end system should protect itself against this kind of malware without being helped by any intermediate station. Not being helped by an internet service provider, not being helped, whoever trusted party would be in between, in order to make sure that some packets are thrown away, not reaching the end system, because, as you know, if you have a virus scanner, you are protected against what is considered currently the most important threats for your machine. You are not protected against everything that is known to these companies who are operating these virus scanners, because if you implement all of that, you cannot work with this machine anymore, because it's only doing this kind of protection. But this is a major concern to me when I'm seeing and also seeing colleagues of me arguing that if we have this end-to-end encryption, then we are basically done. Some colleagues of mine say, when we have this end-to-end encryption for everybody, then we are done with the security issues. We presented at an earlier LCN in my presentation, my keynote on botnets and how to protect yourself against these. You're having a very hard time if you are delivering all these really bad malware with perfect encryption and making sure that nobody in between can help you protect it.
So I have a pet peeve which responds to the previous two questions. It has to do with email. And there is no standard for unsubscribe. So you get these little things in your email that says, safe, unsubscribe, trademark. It's okay to hit that. Of course, I can type safe, unsubscribe, trademark on any email I want, and then I can put all the malware in the world right behind it, and then you will click on it. There should be a standard. This is one of those bad things that's come to the market. There should be a standard for unsubscribe, so you can unsubscribe without executing arbitrary code in your machine. Safe, unsubscribe, indeed.
Especially when you have 26 emails and you're going through it like a rocket, and you screw up and accept something that you really shouldn't have accepted it.
But of course, it was some time ago when the majority of the imperfections was done with some email attachments or things like that. If you encrypt the communication between the web servers and the end systems, then of course you also have nobody to help you when you get infected when visiting some website, which of course is currently the typical vector of attack. Some malware waiting for you to visit some website. Sometimes they help you to find this website, which could be helpful to replace the infection in your machine. But there's also encryption with these machines, which adds a lot of privacy. It helps a lot, but you have to think how to work with this area of protection against the bad guys. Sometimes you want to do something good, and what you do is also have the bad guys. Sometimes you have more good guys.
Jerry, did you have a question? I want to say that dinner is at 7 o'clock, if you didn't already know that. It is inside, and it will be back in that corner over there. So we'll take this as being our last question, and then we can wrap it up.
Thank you. Actually, I do have a follow-up about security, so somebody else brought it up, it wasn't me. I'm a big fan of encryption. For a long time, I have been predicting we're going to have virtual VPNs between every one of us. But I will also claim that dumb users trump good technology. You guys have talked about good technology. What do we do about dumb users?
Well, we're improving the education system.
What do we do about dumb users? Anybody? We have more conferences like this.
Is that a serious question? What do we do about dumb users? Come on, Gary.
To the extent that you come up with good solutions, and I can defeat every single one. Put my father at that computer.
Hey, do you want to hear about a great user interface? There's this user interface that you're familiar with. You put your hands like this on a round thing, and then you go like this as you drive your car. And if you go like this at the wrong time, you kill your whole family. That's it. So what do you do about dumb users in that case? You have this user interface that's capable of killing your whole family just by doing this, and yet we let them do that.
But are we not building cars that will help prevent?
We're working on driverless cars to solve that very problem. So similarly, everything else.
But today we already have a lot of cars which if you do this, the car will not do it.
Really?
Yeah.
I didn't know that. They must be German cars.
Gentlemen, I think we're going to need to leave it at that. I have to say, Francis, this has been a singular pleasure to be on the podium with the likes of you four. I want to thank you very, very much, and we need to give everyone a big round of applause. So, Bills, actually, yes.
It's like, this is what I like.
So, yeah, as usual, we offer also for our panelists certificates of appreciation. I know some of you are not getting a second frame, but yeah, I think that should be okay.
Okay, so first, Bob Metcalfe, thank you very much. And Howard. And Harvey. And I know this is going to come as a really big surprise, Peter, but there's one for you too here. So once again, thank you all very much for attending this session. Thank you for your questions. Thank you, panelists, for the really insightful comments. And please avail yourselves of talking to them. Like I said, they have a lot of opinions. Very good. Thank you again. Dinner at 7 over across the way.